Today we'll be looking at the Yokogawa e-RT3 platform and how you can run custom AI machine vision applications using nothing more than your PLC and a webcam. In this demo, the Yokogawa e-RT3 sends a request to the PC, which captures an image from the webcam and sends it back. The PLC then processes the image using a local AI model to determine the number of fingers being held up in the image. All the heavy lifting here is being done by the e-RT3, with the PC being used to only capture and display images. This is just an example to show that AI inferences run locally on the e-RT3 can be used to drive real-world outputs. Rather than detecting fingers, with the Yokogawa e-RT3 you can run any number of pre-trained AI models with different specialties, or train your own custom model for your specific application. For this tutorial, you're going to need your Yokogawa e-RT3 with RP70 CPU, an input and an output module, DC, a PC, SD card writer, 2 Ethernet cables, a power supply with this switch module or a different way to send an input signal to the e-RT3, as well as a switch or router with connection to the internet. In order to write the OS image onto the SD card, we're going to need a tool called RA-Write, published by NetBSD. I'll provide a link to this in the description. We're going to open our file system image. And these images should have been given to you by Yokogawa. You should have a Debian image and an Ubuntu image. These are flavors of Linux, and an image is simply an operating system. So we're going to be using the Debian image today. Hit open. And I have chosen the wrong drive here. This is my SD card. So make sure you select your SD card and the OS image, and then select write to disk. Note that this will destroy anything that's on your SD card. You cannot have anything else on the SD card other than the operating system. So if you have anything on here, it will be deleted. Hit yes, and this is going to take a few minutes. Okay, that took about 10 or 15 minutes, but now the OS image has been written to the SD card. You'll notice a window pop up showing the new contents of the SD card, as well as a message in the RA-Write tool saying the data was successfully written into the SD card. Now, we'll safely eject the SD card before inserting it into the PLC. With the OS image written to the SD card, we can now remove it, load it into the PLC, power on. We are now watching for the OS light to come on in the corner of the CPU display, indicating that the operating system is running. This can take a couple of minutes on the first boot up. Okay, the light appeared. We are now running the operating system. Next, we're going to connect our PLC to our PC and to the internet to download some files that we're going to need. Connect to slot 1 for the PC. I'm going to plug this into my PC. And slot 2 we will use for our network connection to the internet. This switch is connected on the other side to the internet, so we'll be able to download the files that we need. Okay, now we can see green lights and amber flashing lights on both ports. So we have connection. We're ready to begin the next step. And to set up communication from our PC to the Yokogawa e-RT3 PLC. In order to do this, we'll need to set our IP address to match the IP address of the e-RT3. To do this, I like to use a tool called Simple IP Config. There are also ways to do this without any external tools on Windows. To do so, you're going to need to put in the IP address that you want. The Yokogawa is set to 192.168.3.72, so we need to set our IP address to 192.168.3. something other than 72. Let's go ahead and use 99. Apply. You'll be able to see your IP address is now 3.99. And we can go ahead and open up a PowerShell window and ping the e-RT3 192.168.3.7.2. And if you get these responses, then you can be sure that you're communicating. Next, we're going to connect to the e-RT3 over SSH in order to communicate and load the files that we need. If you've done this before, you can do so from the command line using SSH e-RT3 at 192.168.3.7.2. But if it's your first time, a much more user-friendly approach is to download Visual Studio Code. I will leave a link in the YouTube description. Once you've downloaded it, go ahead and open up the Extensions tab, search for Remote Development, and install the Remote Development extension. Once you do, you'll see the Remote Explorer tab. Switch the top tab to Remotes, and then add a new SSH connection. SSH e-RT3 at 192.168.3.7.2. Select your SSH configuration file. You'll see a pop-up that says host added in the bottom right. Hit connect. It's going to ask you for a password. Your password is default password user_e-RT3. The next thing we'll need to do is set the date and time. The date and time on the e-RT3 may be months or years out of date at this point. So to do so, sudo date-s, year, currently 2025, month, April, day is the 15th. The time is not so important. It doesn't have to be precise. So prompted for the password, it is user_e-RT3. If you've done it correctly, you should see the correct date and time. Next, we'll need to clone the code from my GitHub repository. So navigate to github.com/levi_transtrom/gesture. The code button, copy, and then type git clone, and then paste that with Control-Shift-V. This might take a few minutes. It's going to download the code that I've written from GitHub onto the e-RT3. Okay. When it's finished, you'll see there's now a new folder called gesture. That's where the code lives. Next, we'll need to install the dependencies. To do so, we can use this setup script. To run the setup script, type gesture/setup.sh. This will run through and download the required dependencies of the code so that everything will run properly. And again, this might take a few minutes. I've installed dependencies. We're ready to start up the Python script on the e-RT3. Before we do so, let's check config.yaml. It's going to reach out to your PC at this IP address to get images from your webcam. If you set your IP address to something other than .99 in the beginning, you'll need to set that here to reflect it. Okay? Next, to start up the Python script, you'll need to cd into the gesture directory, and then python3 main.py. You may notice that nothing is happening. The script is running, but it is unable to get images from your PC because the server on the PC is not running. So we'll go ahead and set that up next. To get the image server running on your PC, we're going to need to clone the code onto your PC and install Git and Python. So if you don't have Git and Python for Windows, go ahead and download or install them. Once you do, again, copy the URL, and we're going to go ahead and clone this using PowerShell. Open up a PowerShell window, git clone, and then paste the URL. It will again pull the code from the GitHub repo onto your Windows PC. Next, we'll need to install the requirements to run the image server. To install it, you can find that at install gesture / image service / image server requirements.txt. Pip will install the required packages. I forgot the -r flag. Pip install -r to install requirements from a file. Okay. This may take a minute. I already have them installed on my machine. It may take a minute if you're installing them for the first time. The next thing to do is start up the image server. Change directory into gesture folder, and then run python 3 -m image service .image server. This will start up the image server. Now you can see that there's a blank window open which says detection. It may say not responding. And here is where the images acquired from your webcam will show up after they've been processed by the e-RT3 and the object detection algorithm has been run. Let's try it out. To begin to capture and process images, we'll need to send a 24-volt input signal to slot 1, input 1. To do this, I have Yokogawa's handy switch module. This is really useful for troubleshooting digital inputs, as you can switch on the inputs that you care about. We're just going to be using the first switch. At this point, if you still have your internet line plugged in, we can remove this, as we no longer need to communicate with the internet, only with our image server to send the images from the webcam. So we'll go ahead and plug this in to slot 1. Okay. When we flip on input 1, that sends a signal to the PLC to ask the image service for an image from the webcam. If you leave it on, it will continually ask for more and more pictures. But if we just turn it on briefly and back off, it'll take one picture. And then we'll see that pop up on our display on the PC. It takes a few minutes to process. And there was one finger detected with 0% certainty. So this is not counted as a detection. And you see the alarm come on, indicating that no number of fingers was reliably detected. To increase the quality of your detections, I recommend good lighting and a plain background. If you look closely at your output module, you'll see that the digital output corresponding to the number of fingers being held up is activated. This is just an example to show that AI inferences run locally on the e-RT3 can be used to drive real-world outputs. Rather than detecting fingers, with the Yokogawa e-RT3 you can run any number of pre-trained AI models with different specialties, or train your own custom model for your specific application. Thank you for watching.